Hello everybody. Today in this video we are going to discuss quicksort algorithm. Quicksort algorithm is also one of the sorting algorithm which is based on divide and conquer. In this quicksort we have to pick an element as a pivot element. Okay, in this quicksort we have to take one element as a pivot element and we have to do a partitioning of the array. We have to do partitioning of the array and we have to arrange the elements of the array around the pivot element. We have to arrange the elements in such a way that the elements which are smaller than pivot element should be placed at the left side of the pivot element, and the elements which are greater than pivot element should be at the right side. Okay, and then the pivot element automatically will come at its correct position. This is what the quicksort definition defines. And now let us discuss working of quicksort. First of all, we have to choose one of the element. Okay, we have to choose one of the element as a pivot element from the given array. We can choose pivot element randomly, or else we can take first element of the array as pivot element, or we can take last element, or we can also take the middle element of the array. Okay, we can choose any element as pivot element among the given array. Okay, next we have to do partitioning of the array. Here we have to rearrange the elements of the given array around the pivot element. As I said before, after partitioning, the element smaller than pivot element will be on its left side, and all the elements greater than the pivot element will be on its right side, and then the pivot element will be at its correct position. Okay, and then we have to take the index of the pivot element. We have to do it recursively. Okay, in the third step we have to do it recursively. We have to call it recursively until we get a sorted base case. Okay, we have to do partitioning on both left and right subarray. After partitioning the given array to two subarrays, we have to do it recursively on other subarrays also. We have to do it until we get a base case. Here that's what I have wrote, base case. The recursion stops when there is only one element. As I said before, we have to get the base case after doing partitioning recursively. Okay, then we have to stop the recursion. Now let us understand quicksort by using this example. Here I am going to solve this given array which is unsorted array. I am going to solve this using quicksort. Here I can take any element as pivot element. Either I can take this as pivot element or this as pivot element, or any random element I can pick as pivot element. Here I am going to take this 21 as pivot element. Okay, we have to arrange these elements around this pivot element only. So I am taking this 21. We have to arrange the elements in such a way that the number which are smaller than 21 should be at left side, and number which are greater than 21 should be at a right side. You can simply do that manually, right? Here let me take this 22. 22 is greater than or smaller than 21. Yeah, it is 22 is greater than 21. So I have to place it at right side. Okay. And now moving towards another element. Here 18. 18 is smaller than 21. So it will come at a left side, right? It will come at right side. And again 39 is greater than 21, so it will come at right side, 39. Okay, and now 10 is smaller than 21, so it will come at left side. Again 34 is greater than 21, so it will go at right side, 34. The order may change. Okay, this is our pivot element. I have taken extra one. These order may change. Okay, this may be in any order, it doesn't matter. We have to sort these parts subarrays again recursively until we get a sorted array. Okay, again we have to take these two subarrays, 18 and 10. Okay, and 22, 39, 34. 21 will be at its place because it is already sorted, so we don't need to do anything about this pivot element. Okay, now we have to arrange these elements. You can arrange manually. You can see that 18 is greater than 10, so it will come at right side. So 10, 18. I am doing it manually. We will do according to algorithm in the next part. Okay, here 21 will be at its place, and now here you can see that 31 is the greatest element here. Okay, we have to let's take this as pivot element. Okay, pivot element. If we rearrange these elements, that 21 will be come at left side only, so it will be at its left side. If we compare these two elements, 34 is smaller than 39, so it will come before 39, after, that is after 22. So we have to arrange 39. Now it is sorted. Now you can write it in order 21, 22, 34 and 39. Now you can see that it is in a arranging order. Okay, now it is sorted. This is how the quick sort work. Now let us discuss the algorithm and let us solve the problem according to algorithm, and we will understand the analysis of the quick sort also. Now let us discuss the quick sort algorithm. Here we are going to apply quick sort on subarrays to sort the array. Okay, here we are going to sort a subarray by quick sort. Here we are taking input as a subarray of the original array defined by its left and right indices. Okay, in the output we will get a sorted subarray along with right and left subarrays. Okay, which are sorted in non-decreasing order. If here left element is smaller than right, then we have to perform these steps. Here S is the split position. Okay, from where we are going to do partitioning of the array. Okay, and here and after splitting the array, we will get to subarrays, right? We have to we have to apply quick sort on those subarrays. Here we are applying quick sort on the left subarray, that is left index of the subarray to the splitting position. Okay, and here we are applying quick sort on another subarray, that is right subarray, from the splitting position to the right subarray. Is it visible? Here. Okay, here we are applying quick sort on another subarray, that is from splitting position to the right index of the another subarray, right? Here we have partitioning algorithm. Here we have partitioning algorithm. Using this we are going to solve our problem using quick sort. Okay, this is the important algorithm. Here we are going to do partition of those left subarrays and right subarrays, right? Here we are taking input of array, same. Here also we are taking subarrays of array, that is a of 0 to n minus 1, that is the original question. We are going to take subarrays of this original array, which are defined by its left and right indices. Okay, in the output we will get the partition of this array. Okay, along with the splitting position. Here P is the pivot element. Okay, pivot element. Here pivot element, in most of the cases the pivot element is considered as the first element of the array. Okay, we may take any element, but in most of the cases always we consider first element of the array. Here first element is at the left side, right? We have taken that first element. They have taken that first element, A of L. Okay, then we have to do iteration. We have to do iteration along both sides, on left side as well as in the right side. Okay, in the left side we have to do incrementation, and while at the right side we have to do decrementation. Sorry, here, and you have to repeat that step. As I said, in the if A of I, that is if the element is greater than the pivot element, right? If the element is greater than pivot element, we have to do incrementation on the right side. Okay, and if the element is less than the pivot element, right, less than or equal to pivot element, we have to do decrementation. We have to move towards left side. Okay, then we have to do swapping of those elements. We have to do it until we'll get the element which is equal to or greater than the first element. Okay, we have to do it until I is greater than or equal to j. We will understand it more clearly when we solve the problem. Okay, and then we have to do swapping of the of a of I with a of j, a of j, and that is we have to do swapping with the pivot element. If I and j crosses each other while doing the iteration, then we have to swap the elements with the pivot element. Okay, and then we have to return the j. Let's understand it more clearly by solving the problem. Now let's solve the problem using quick sort. Here I have taken an array which is unsorted. Here 6 1 2 3 7, it will go up to infinity. Okay, here we have to choose pivot element first. Okay, let's do it using the algorithm. Here we have to choose the pivot element as the first element of the array. Okay, this is our pivot element. Now this is pivot element a of l, that is a of, this is left side only, no, right, a of l. Okay, now we have to initialize the elements, left side of element as I and j, j as from the last it is, we have to initialize this element as I and this element as j. It will move towards left side and it will move towards right side. Okay, it will stop only when we will get the element. We have to do iteration, right? It will only stop when we will get the element which is greater than 5. While doing iteration, if we get the element which is greater than 5, then the I will stop there, and we have to perform iteration towards left side using this this j. Here it will move towards left side, right? Here this will stop only when it will get the element which is less than pivot element. Okay, now let's do it. Here I'm using this algorithm. Here I have to take a of I first. Here we have a of I which is greater than or equal to p, right? I'm going to do according to this. A of I which is greater than equal to p, and if we have to do incrementation. Now a of I, here a of I is first element is a of I, that is 1. We have pivot element as 5. A of 1 is 3. 3 is less than 5, so we can't do any swapping here, so we have to move further. We will move here. 1 is greater than or equal to 5, no, it is smaller than, so we have to move further. Here 9 is greater than 5, so I have to stop here. I will come here. Okay, I will come there, and now we have to do iteration along left side. Here j will stop only when it will get the number which is smaller than pivot element. Okay, here you can see that, right? J of j, a of j is less than equal to p, and then we have to do incrementation along left side, that is j minus 1. Here a of j, that is a of 7, we have pivot element as 5. A of 7 is 7, which is greater than 5, so we can't do any swapping, so we'll move further. Here 4 is smaller than 5, right? J will stop here. Okay, now we have to swap these two elements here. Okay, we will get 5 3 1. If we swap 9 with 4, we will get 4 8 2 9 7. Okay, pivot is here itself, this is our p. I have stopped, I is stopped here and j has stopped here, and now we have to do same procedure. Okay, now I is here, right? A of I greater than p, I plus 1. Here 4 is not greater than 5, right? We have to move further. Here will come 8 is greater than 5, you can see that, right? 8 is greater than 5, so I will stop here. Now do iteration along left side. 9 a of j less than b, j minus 1, right? A of j, where is j? J is here. A of 6, we have pivot element 5. A of 6 is 9. 9 is less than 5? No. So we have to move further. Here 2. 2 is less than 5, right? We have to stop here. J will stop here, right? Now we got the elements. Now we have to swap these two elements. Okay, the 2 will come at the place of 8 and 8 will go at the place of 2. We will get 5, 3, 1, 4, 2, 8. Right? I have swapped these two elements. 9, 7. Okay. Pivot is still here. It has not got its position. Now I am going to repeat the same step. I has stopped here and j has stopped here. Right. Now again doing the same procedure. Here j. Here a of 4, we have pivot element 5. A of 4 is 2. 2 is not greater than 5, so we have to move further here, right? 8 is greater than 5, so I will stop here, right? Now moving this j a of j is at 8, right? 8 is not smaller than 5, so we have to move further 2, right? 2 is smaller than 5, yet here we have to stop at this 2. So you can observe that the I and j has crossed each other. In this case we have to do swapping with the pivot element. The j will swap with the pivot element, right? This is the main thing which we have to keep in mind. Here when I and j cross each other, then we have to swap j with the pivot element. Okay, this is the main thing we have to remember. Okay, now after swapping I will get at the place of 5 2 will come, and at the place of 2 5 will go there, right? Okay, 2 3 1, here 2 3 1 4, here is 5 8 9 7. Now our pivot element is at the middle. It has got its position. Now you can see that the element at the left side all are smaller than pivot element, and the element which are at the right side are all greater than pivot element, right? This is pass 1 we have completed. Up to this we have done only pass 1, and in further case we have to apply same for these subarrays. Okay. Now we have to apply same procedure for these two subarrays. Okay, let's solve this further. Here I have taken that sorted array. The pivot is at its position, that is middle position. Now we have got two subarrays here. We have to apply same procedure here on both sides. Now let's solve this first. Here this is our pivot element. Consider this as pivot element. Okay, pivot element, and this is our I and this is our j. Here we have plus infinity. A of I should be greater than or equal to p, and I will increment on each step, and here A of j should be less than or equal to p. J will increment on each step. Here we have A of 1, and pivot element is 2, right? As I said before, I will stop only when we get element which is greater than our pivot element. Here A of 1 is 3. 3 is greater than 2, right? It will stop here, and we have to move this j further, right? A of j is 3. A will stop only when we get a number less than pivot element. We have pivot element as 2, right? We have to get the element which should be less than pivot element. Pivot is 2. A of 3 is 4. 4 is not less than 2, right? We have to move further. Here it will come j. 1 is less than 2, right? We have to stop here. Now we have to swap these two elements. The swapping of pivot element only take place only when j and I cross each other, right? Only then we have to swap this pivot element with j. Okay, this is a main point we have to remember. we have to swap these two. We will get 2, 1, 3, 4. 5 will be at its place. We have this pivot element and 7. Right? Again I is here, J is here. Right? This is our pivot element. Pivot element. A of I plus 1. Again, I is here, 0, 1, 2, 3. A of 1, this 2. A of 1 is 1. 1 is not greater than 2, right? Moving further, I will move further, and 3. 3 is greater than 2. Yes, right? Now we have to move this J. A of J. Here J is 2, and J's index is 2, and pivot element we have is 2. A of 2 is 3. 3 is less than 2, no, right? We have to move further. Now J will come here. 1 is less than 2, yes. Now see here, I and J has crossed each other. Now I have to swap this J element with the pivot element. Okay, then I will get the position of this pivot element. I am going to swap this pivot element with this J element. Okay, we will get 1, 2, 3, 4. Our pivot element is at its position. Now you can see that these elements have sorted. Right? You can see the elements which are smaller than is at left side, and the element greater than this pivot element are at right side. Right? So it has sorted. Now this part we have to solve. This will be at its place only. This here we have 8, 9, 7, 0, 1, 2. Now I am going to consider this element as pivot element. Right? Applying same funda here also. A of I greater than B. I plus 1. A of J, B, J plus 1. Right. Here is our I, here is our J. Now A of 1 should be greater than our pivot. Pivot is 8. A of 1 is 9. 9 is greater than 8, right? So I have to stop here only. Now moving this J. A of 7 should be greater than, should be smaller than our pivot element. 8, right? Pivot is 8. Yes. Sorry, here A of 2. Pivot is 8. A of 2 is 7. 7 is less than 8, right? So J will stop here. So now we have to swap these two elements. So we will get 5. I'm going to swap these two elements, 7, 9. Right? Again, our I is here, our J is here. Now I'm going to do same procedure for this. Our pivot is 8. This is 0, 1, 2. Here we have plus infinity. A of I should be greater than our pivot element. Then we have to do increment here. Here I is at 1. A of 1. Pivot is 8. A of 1 is 7. 7 is greater than 8. No, right? We have to do incrementation. So I will move further. Here 9. 9 is greater than 8, right? So I will stop here and moving this J. A of J. A of 2. J is at index 2. Right? Pivot is 8. A of 2 is 9. Is 9 less than 8? No, right? We have to move further. So J will move further here. Then A of 1. A of 1 should be less than our pivot element 8. A of 1 is 7. Is 7 less than 8? Right. 7 is less than 8. So J will stop here. So you can see that here I and J has crossed each other. So we are going to swap it with pivot element or pivot element. J will swap with pivot element. So we will get 1, 2, 3, 4, 5. I'm going to swap these two. here 7, 8, 9. This is our pivot element. Now you can see that here this is our pivot element. Now you can see that the element at the left side is smaller than pivot element and the element at the right side is greater than pivot element. Now you can see that the whole array has been sorted, right? This is how the quicksort works. You can see here we have sorted whole array 7, 8, 9. Our pivot element, first in the first pass we have this as our pivot element, right? This is our pivot element. We have arranged all elements which are less than pivot element at the left side and the greater elements at the right side, right? This is how quicksort work. Now let us see the analysis of this quicksort. Now let's see the analysis of quicksort. The time complexity of this quicksort at average case is n log n, and at worst case it is n square, and at best case it is n log n. Okay. Now let me write the recurrence relation of the best case first. Recurrence relation of best case is given by C best of n equals to 2 C best n by 2 plus n. Here n by 2, because we are dividing the array, right? We are going to divide the array into 2 subarrays. That's why this n by 2 will come, and we are going to do it n times, right? On n or on n elements, right? So this is the n. This is for n is equals to 1, and for C best when n equals to 1 we will get 0. Okay, and the recurrence relation for worst case we will get recurrence relation for worst case. This is for best case, this is for worst case. This is C worst of n equals to n plus 1 plus n minus 3 to root of n square. In the worst case we will get n square. This is because when we do partition we will get the unbalanced sorted array. So at that case we will get the recurrence, that is time complexity of this quicksort is n square. Only on those particular cases the worst case will be n square, and the recurrence relation of average case is for average case. So this is the recurrence relation of average case. This is for only when n is greater than 1. If n is equals to 0 then we will get 0, and if n is equal to 1 then also we will get 0. Now let us solve this now let us do analysis using the Master's theorem. Here if we have number of key comparisons before partitioning, then we have n plus 1, right? And if we do if we scan the array of n elements which contain n elements, and if they coincide or cross with each other while splitting, then we have a recurrence relation. This T of n is equals to 2t n by 2 plus n. This n by 2, because we are splitting, right? We are dividing the array into 2 subarrays. So this is n by 2. Now let's solve this. This is for n is only when n is greater than 1. Let's take this as equation 1. We have to write recurrence relation using this. For this n by 2 we will get n by 2 equals to 2t n by 2 plus n by 2. This is our equation 2. Now substitute this equation in this equation. Substitute equation 2 in equation 1. At place of t of n by 2 we have to substitute this. Then we will get t of n equals to 2 into 2 t of n by Here I have multiplied this 2 to this part and this part. So we will get 40 n by 4 plus this 2 will get cancelled, n plus n. So we will get 40 n by 4 plus 2n. n plus n is 2. So this is our t of n. If we write for this n by 4, then we will get a recurrence relation as t of n by 4 . If we solve for this, we will get this equation. For ith element, we will get for ith iteration. For ith iteration, we will get t of n equals to t of I. Here we can write this as 2 power 3, right? So 2 power I plus I of n. We will get this equation for ith iteration. This equation. We consider this n by 2 power I equals to 1. If we take this 2 power I here, we will get n equals to 2 power I. Then it will give I equals to log base 2 power n. Right? It will give this. Now substitute these values in equation. Then we will get our recurrence relation. I am going to substitute these values in this equation. Then we will get 2 of I is equals to n, right? In place of 2 of I am going to place n t. N by n. At 2 to the power I am going to write n plus I is log base 2n and this n as it is. This n will get cancelled. Then here we have left with 1 log base 2 power n into n. Okay. Now here t of 1 is equals to 1, right? Into 1 we will get only n plus this is n log 2n. So this is our recurrence relation after analyzing using master theorem. This is the analysis of quicksort. So thank you for watching my video. If you have understood, please subscribe to my YouTube channel.